Hello, everyone. On behalf of IBM Systems Magazine, I'd like to welcome you to our presentation. My name is Janine Donnelly. I'm the manager of webinars for IBM Systems Magazine, and I will be the moderator for today's event. We will be holding a Q&A session at the end of our webinar. You may ask a question at any time during the event by entering it into the Q&A panel. If you experience technical difficulties during the webinar, please use the Q&A panel to alert us, and someone will assist you. You may download a PDF version of the slide deck by clicking on the drop-down menu labeled Event Resources on the left of your screen. Today's webinar, Mainframe API, Taking You into the Future, is sponsored by G2 Software. Our featured speakers today are Don Spoerke and Harry McCord. Don is the Director of Product Management for G2 Software, a 25-year veteran in the enterprise modernization space. Don has collaborated with an impressive list of global fortune companies to intelligently integrate legacy mainframe assets to scale for new business application initiatives. Don provides technical and strategic vision for organizations that wish to expand the role of the mainframe to integrate into new technologies like mobile and web applications, as well as cloud-based solutions. Harry is the Director of Application Management for all of Educational Testing Services brands. Educational Testing Service develops, administers, and scores more than 50 million tests a year. Previously, Harry served as the Vice President of ASAP Systems of Merrill Lynch and as the Chief Technology Officer of Wired Vines. Harry has over 30 years of experience in technology engineering and management. Today, Don and Harry will discuss many of today's questions on the API economy, as well as explore best practices for bringing these processes to your mainframe applications. With our introduction complete, Don, I'll turn the presentation over to you.
Thank you, Janine, and welcome to today's webinar, Mainframe APIs, Taking You into the Future. Over the next 45 minutes or so, we'll explore the evolution of APIs and talk about how the mainframe is an active and participating player in the API economy. So let's start out by discussing the role and the evolution of the API. Application programming interfaces have been around for decades, and point-to-point solutions of the 60s, 70s, and 80s, well, they actually got the job done. The challenge was that they're very expensive to create and maintain, highly specific to what you're connecting. In other words, not very flexible and certainly not reusable. I think we all knew that point-to-point solutions were not going to take us very deep into the future. But we learned a great deal from point-to-point solutions. So organizations worked very hard to create interfaces that were reusable. The challenge here is that they were only reusable for their own purposes, and they were still highly dependent on the resources inside of an organization to maintain. As the resources moved to other areas, retired, or quit, we see the custom connectors as a serious drain on an organization. So, although the intention was noble, the results were certainly not. Now, that doesn't mean we're not getting closer to a common solution, and hope is on the horizon. With the introduction of service-oriented architecture, or SOA, notably SOAP XML-based, it opened up a whole new era in application development and integration. It seemed that we'd finally had a common standard and interface for connecting applications. Now, it wasn't long after the introduction of SOAP and SOA that GT Software began creating our Ivory Service Architect product. We realized very early on that having the mainframe be a full participation in the API evolution would provide countless benefits to our customers and prospects. We also realized that the people creating the APIs may not be familiar with all this new web service API terminology, so we designed our product with that in mind. You'll see later in the presentation that Ivory Service Architect has the power and flexibility to bring the mainframe into the API economy. But even as the industry-leading integration vendor, we simply couldn't rest on our laurels because the evolution was continuing. Today, we have what IBM calls the API economy, driven by the Internet of Things and the need to expose more information at a faster pace. APIs have become the new gold standard for application exposure and integration. Now, several things have changed in the new API economy. First, the message format is moving away from SOAP to REST, probably because the REST message format is more appropriate for mobile and device integration. And this is critical as more and more apps are being created to combine information from a variety of sources. Also, from a device perspective, more of our day-to-day information interactions are moving from the traditional PC interface to some sort of mobile interface. I think we can all agree that the API is pretty much here to stay. Now, I think it's fair to say the API evolution has transformed into the API revolution. The explosion of internal, company-focused APIs and industry-available APIs is seen in this graph. In just 8 years, from 2004 to 2011, we went from next to nothing to well over 4,000 commercial APIs. I can't even begin to guess how many we have now in 2017. To that point, GT Software has customers that have created and have in production well over 200 APIs that expose mainframe applications and rates of execution well over 40 million invocations per month. Let me say that again in case you missed it. Hundreds of mainframe APIs and over 40 million invocations per month. And that's just one customer, and we have a lot of them, and this is something that we're very, very proud of. So let's switch gears and talk about why APIs are so important and how easy is it for you to integrate the mainframe into this revolution. Let's explore a little deeper the world today and what IBM calls the API economy, where APIs become the means by which digital enterprises do business. Many of the web and mobile sites we interact with on a daily basis are built upon APIs, which can be private or public. In the API economy, there's providers and consumers. And most important, they represent an amalgamation of information from different sources. If you think about a typical car buying site, not only can you search for the specific vehicle you're interested in, but you can get competitive vehicles from different manufacturers, financing information, a loan calculator, insurance rating information, and even a vehicle history for used cars. Now, pulling this information from various sources is truly the power of the API. So as we've seen, APIs are not new, and they've been evolving over the past several decades. The key is common standards by which providers and consumers can easily communicate across. SOAP XML and REST JSON are now the standards which most APIs follow. So now the burning question becomes, what does this have to do with the mainframe? Well, the answer is pretty simple. What if the information you're looking for is on the mainframe? Organizations that have mainframes rely heavily on the applications and data housed there for the operations of their business. But despite how powerful mainframes have been over the past 50 years, there still remains a challenge of how to easily integrate to the applications and data that reside on them. Mainframes just don't click into the distributed systems world. So too many times projects either stall or worse, get canceled because it's just too hard to get that information that resides on the mainframe. Or we step back to our comfort zone of the 80s and do some technical gymnastics to create a custom solution. And we all know how that's worked out. So let's think of a better way to solve this issue. Let's assume you're able to get some APIs or connectors created. Most of all these mainframe connectors are geared toward executing a single online transaction or program, such as get part or get order. Now that's going to get you partway down the road, but more often than not, the business requirements are much more complex, requiring a combination of these atomic level APIs to be invoked in a specific order with intelligent processing around them. And what does that mean to all of us? That means coding. But to get to a level of reusability and flexibility, there's got to be a better alternative than coding. The better way is to create a layer of more intelligent APIs, combining the atomic transactional level APIs with an intelligent workflow designed around the business process. These composite APIs provide a much more useful set of business services, which makes it easier for each consuming front-end application to integrate to them. By orchestrating these APIs together, you get a greater reusability and agility to respond to new business requirements. So the only problem now to solve is what's the best method for creating these business-level APIs. And that's where GT Software and our industry-leading mainframe API development product, Ivory Service Architect, bring everything together. With Ivory, not only can you create the atomic APIs easier than before, but you also have the choice of the back-end connector technology to get to that mainframe. So what this means is, if you want to get to the data, why not wrap your SQL request to the mainframe with an API call? We can do that. If the green screens are the only way to get through to your application, we can wrap that with an API, and that could be TN3270, BMS, or MFS-based green screen applications. For CICS and IMS programs and transactions, you see that I have CTG and IMS Connect marked as optional. If you choose to run our Ivory server on the mainframe, either as a started task in CICS or on the integrated facility for Linux, they are truly optional. But you also have the choice to run the server off of the mainframe if you wish, giving you complete control of how to allocate your resources. Ivory Service Architect also allows you to add an orchestration process between the mainframe APIs and the consuming applications. Let Ivory handle and coordinate the execution of multiple transactions. This eliminates the low-level development work, and complexities get eliminated. Now you have the ability to create APIs that have more closely mirror business operations. So when an API designed to get customer is invoked, it has the intelligence to get customer information from across multiple sources. For example, in banking, it could be checking, savings, loans, credit cards, all those pulled together into a single API. Consuming front-end applications don't have to replicate that logic. They simply make one call. And these business APIs are shareable and reusable across different consumer applications. Any changes you make in business operations that the APIs represent can be made more easily and a lower cost. So what you end up with is GT Software's Ivory Service Architect is the API creation and orchestration technology for real-time interaction with IBM mainframe-based applications running under both ZOS and VSE. It provides an easy-to-use development environment requiring minimal knowledge of the mainframe. If you know or can find the transaction IDs or program names of your mainframe applications and their input-output copybooks, you can create a mainframe API. If you can connect icons together in a graphical interface, you can build a mainframe API. If you've ever used a wizard in a computer application, you can build a mainframe API. And if you understand how one application relates to another you can build an orchestration layer. It's all point and click, drag and drop. I've literally had new users building APIs against mainframes in less than 1 hour. Now, Ivory Service Architect is an incredibly rich product for building mainframe APIs, but the power of API orchestration really takes this to another level. An Ivory orchestration is like assembling Lego pieces in an intelligent, interactive sequence using the Ivory Studio that you see here. In the example, you may call a legacy CICS COM area program. Then, based on the returned result data, you may call an external web service, and then follow that with a dialogue with a 3270 application. When complete, the orchestration itself becomes a bigger Lego piece that can be easily integrated with the consuming applications. So in these composite APIs, you can include multiple transactions, multiple data sources, external web services. You can add conditional logic in for things like checking return codes. You can set up custom error handling, governance and security. And because this is a drag and drop SDK, there's no coding that's required. No coding to get to the back-end connectors as well. And finally, the mainframe itself can be a web service consumer. And I think Harry's going to touch on that a little bit today when he talks about how their mainframe applications actually make calls to an external service provider. Now, the Ivory Studio also has some other very, very powerful features. One of them being a wizard. So if you know nothing about mainframe applications except for the name of the program and what data fields need to be put in, we have a wizard that will step you through the entire process to build the basis for your orchestration flows. We can create services as either from a SOAP or a RESTful perspective. And those orchestrations can be exposed as SOAP or REST. We've got an onboard testing tool that we can use, and that testing tool has multiple levels of integration in it. And once you've got a test case that is working and does what you need it to do, you can save that data to run regression tests as you make your changes down the road. Now, one example of the power of Ivory Service Architect, beyond just the website examples we talked about earlier, is that most business intelligence and analytics software packages can easily integrate with Ivory's REST and SOAP APIs as a data source. This is particularly important for real-time and self-service analytics, where you still need governance in terms of what data is made available to the analyst or the user. An Ivory orchestration, by its very nature, is a governance layer, filtering what data is returned from the system of record on the mainframe. Ivory can also be used to helps to reduce the amount of IT support needed for these analytics. Business analysts, under the direction and guidance of IT, can use Ivory to build their own orchestrations to bring back system of record data from the mainframe, which can be invoked real-time or loaded into a warehouse or some other place. And this can be particularly useful for doing data validation, lookups, and etc. Ivory's ability to provide real-time system of record data from the mainframe can also help to eliminate costly and time-consuming ETL processes. So let's summarize the benefits of orchestration using Ivory Service Architect. Not only is it critical for a variety of reasons to include your mainframe into your API strategy, but by adding orchestration, you get many added benefits. First, being improves business efficiency, and there's 2 points here. First, Ivory greatly increases the speed to create APIs. We've seen anywhere from a 5x to 100x improvement in API creation efficiency. And number 2, eliminating the need to do elaborate coding all leads to greater efficiency. Lowering your operational costs. So not only does your development costs go down, but there's several other ways to reduce costs. Because all the work is done on the mainframe, the network traffic is reduced in comparison to doing a series of atomic APIs. If you run the server off the mainframe, you can reduce costs there too. Responding to your competition, there's really no comparison between coding and point and click when you need to be reactive. My experience is that the life cycle of APIs is iterative and will require many revisions along the way. Each change you make will save you money in development costs. Enhancing your customer experience. The more information that you can add to your application and the faster it responds, the happier your users will be. And by saving money on development and runtime, along with having happy customers, should all contribute to increasing revenue. In my mind, everybody wins. Now, it's one thing to hear it from a vendor, but it means a whole lot more when you hear it from someone who has firsthand experience with the power of Ivory Service Architect. So I'm going to turn the presentation over to Harry McCord, Director of IT, ETS Brands and Applications, and have him share his experiences with Ivory Service Architect. Harry?
Thanks, Don. Just wanted to come back and continue this conversation. So when I started at ETS about 5 years ago, a little over 5 years, I had come in and the mainframe technology platform for most of the brand systems the core systems were all mainframe-based systems. So all of our legacy information, all of our main operations were based on mainframe legacy systems that have been around for 20, 30 years. The problem is that they were not keeping up with or able to interact with all the newer web-based technologies. So we wanted to put web front ends, mobile devices, all the different technology platforms that we could put in that would take advantage of newer technologies but still allow us to capitalize on the investment and of our legacy systems. It was a huge challenge because at the time, I can remember the first time I went into an architectural meeting where we were talking about a solution design, and the solution design talked about using FTP file transfer. So going back to your original slides at the beginning of the point-to-point data transfer, sending information back and forth, but not reusable, highly customized, just became, it was a huge issue. So we were stuck in the rut of, and like many companies, where we only had two solutions that we used at ETS for technology. We used FTP file transfers and we used MQ for interoperability. So our challenge was, the first challenge that we got hit with was with credit card processing. We needed to become PCI compliant. On the mainframe data side, that meant that our data that we were storing, because we were storing credit card information in the mainframe data stores, and then we had to process them in batch at night. So not only did we have a problem of, like the timing delay and whether the transaction would truly be approved or denied, it really was not an efficient, good customer service model. So we went and took a look at, okay, well, can we change our mainframe processing to use real-time credit card processing? And our credit card provider, they had the capability to open a web service to us. We just had no way to consume it. And the other challenge that we had is about half of our shop is CICS-based transactions, and the other half of our shop is IDMS-based transactions. So there's two different worlds on the mainframe that we had to be able to support. So we looked across multiple products, and I had experience with other products for mainframe technology, but predominantly in the CICS world. Well, IDMS threw a whole curve into that model. But with GT, I could run support both with the same software. With Ivory Server can support IDMS, and it could also support my CICS requirement. So we were able to go from doing a proof of concept to doing an actual implementation and justification within about 6 months. And that was not development time. Our development time ended up actually being fairly nominal, because once we had the SOAP WSDL definition, we were able to generate, essentially using the Ivory Server tools, we were able to generate the copybook interface for the COBOL program. Okay, so all of a sudden, we had tools that took away a lot of the customized programming. So Ivory Server really proved to be a time saver for us in that process. So we were able to bring this up, save a significant amount of money, because the alternative for us would have been to keep the existing process, would have been to upgrade all of our storage and database technologies to include encryption, which would have been a pretty big issue in our world, so from a cost standpoint. So we went to real-time credit card processing across multiple application systems, some of which were CICS and some of which were IDMS, in a relatively short period of time, and it was a very positive experience for us. And so what we ended up doing is that we quickly adopted that into a way for us for financial transaction processing. Again, we were posting transactions at night, which would then, in the batch process, that would then post that into PeopleSoft. We were able to change that process so that essentially all the mainframe applications, whether they were IDMS or whether they were CICS or batch, were all using MQ to basically send financial transactions that needed to be posted to an interim data store. And then that data store, we had a process that was actually connecting to PeopleSoft real time and processing those transactions that had queued up in MQ. So the sending applications would not have to deal with whether it was delivered or not. They were just using the send and forget of MQ, and then this other application that we built that actually did the transmission to PeopleSoft actually dealt with whether it had been received, whether it hadn't, if we had to do retries, the logging, the queuing, everything. But it again saved us a lot of time, money, and put us in a much better technology and operational space because we were able to do it real time. So we had the needs that we had were the ability to post to PeopleSoft. We had the real-time credit card processing and approval. We have web front ends that we've added to our applications that we needed to be able to do location tracking using geocode so that the test taker would be able to identify the test centers that were closest to them. So when they go in, they have to have the ability to look them up. In order to get the geocode information, we have to actually go and call the Google service, which is a REST service. So we went from using an outbound for real-time credit card processing, an outbound SOAP call from the mainframe to a service, and we went from that to then opening up SOAP transactions on the mainframe that could be consumed by any of our internal systems. We also started to consume outbound REST services like Google, and we also opened ourselves up for REST inbound transactions to get information from our mainframe data stores. So essentially, the tool allowed us to very quickly, as we needed to identify an interface or service an interface or access an interface, it gave us the ability to react to that. So in our world, we had, like I said, we had the we had mainframe transaction let me bring this up, sorry. Mainframe transaction processor with MQ. We had real-time credit card transactions. We had security incident tracking and monitoring with inbound and outbound REST transactions, which in our business is huge because of international testing. We have to be able to track security and possible test incidents around the world real-time. Geocode and Google services. Exposure of numerous lookup and transactions, so it opened us up to basically be truly interoperable with all of the other systems in the ETS portfolio. So now the mainframe, instead of being on an island where the only way that anybody could talk to it was either through FTP file transfers or through MQ, was now basically in a much stronger space, because now it could also communicate and be interoperable with any system using REST or SOAP services. So now we play in the same space, the mainframe plays in the same space as all of the server-based technologies that we use and that many of the vendors that we have use. But what we found over time is that we also have a much stronger experience, because what we also see is a lot of the server-based technologies don't really understand the value of an MQ or the value of a FTP file transfer, and especially in large batch volumes. So we get, now where we get into discussions on design where the designer is saying, "Hey, we're going to use we're going to use a web service," and we're saying, "Well, maybe you should use an FTP file transfer because you're sending a couple million records." So there are, it all becomes part of a toolbox. And the beauty of using the GT product is that it serviced our need for IDMS and CICS. It is very easy for our folks to pick up and use. They didn't have to custom code. It gave them the ability to take a WSDL or an interface definition and generate the copybook that could be then programmed to by the programmer, which was something they were very comfortable doing. So we were able to reduce our time to bring things up, and at the same time drive our costs down and provide ourselves with true interoperability. So that, from our standpoint, the thing that we went from in our systems internally at ETS was our interoperability toolbox, which I personally feel is one of the biggest issues that the mainframe has. We have the power, we have the security, we have the MIPS, we have all the things of a high-performance system and box. We have the ability to support our applications, but we need to have that ability to interface with everybody, and it has to be something that can be reusable, as Don said, and drive it and not have custom interfaces for everything. And that's one of the things that the GT product gave us the ability to do in both of our environments. And the one thing to add on to that is that Don's solution and the Ivory server solution is where you could have an external box or you could run it natively. And we run it natively as a task in CICS on the mainframe in ZOS, and we also run it for IDMS. And I'm going to turn it back to you, Don.
Well, thank you, Harry. I very much appreciate it, and I think everyone would agree that was a really great testimonial to the power of GT Software's Ivory Service Architect. So let's quickly recap, and then we can answer some questions. In my mind, the choice is pretty simple. We've heard a lot about API creation. We've talked some about orchestration. We've heard from Harry about the power of GT's Ivory. In my mind, you can go out and create a bunch of APIs and code them together, or you can create APIs using Ivory Service Architect and get the job done in a fraction of the time. So who is GT Software, by the way? We've been available, or we've been in business since 1982, and our focus has always been around the mainframe and continues to be around the mainframe for strategic business initiatives. We've got a wide variety of customers worldwide, and if you'd like more information, you can certainly find us at our website, www.gtsoftware.com. You'll also see that we've got a whole series of really critical partners that help us on a day-to-day basis. So before we take questions and answers, I'd just like to personally thank everyone for their time today. My hope is that you found the information timely and valuable. The mainframe is here to stay, and we at GT Software strive to allow you to maximize the value you find in it by API enabling your mainframe to take you into the future. So at this point, I'm going to go ahead and take some questions, and as Janine mentioned, if you do have a question, and we do have some that have already come in, you can enter it in the question box at the bottom of your interface. The first question, I'm actually going to pop back over to Harry. Who did the development of the APIs at ETS? Was it the mainframe developers or some business analysts?
So in ETS, we have multiple teams. What I did was I assigned one of my developers to actually go through all the classes. I had a couple of them go through the GT classes so we could become familiar with Ivory. And that person, along with two backups, actually generate the interfaces that are needed with Ivory, and then work, and they're developers, they're mainframe developers, and some are actually, one is CICS and the other two were IDMS developers, and they actually maintain those interfaces and work with the developers on the teams that support the actual applications, so that when a copybook is generated for them, that they can then work with the copybook and integrate it into their module.
Great, thank you. The next question that has come in, how will Ivory Service differ from IBM's? Is Ivory Service Architect a started task in ZOS so that all API requests created through Ivory go through that started task? That's actually a great question, and Harry somewhat alluded to the answer earlier, as did I. If you want to run the Ivory server on the mainframe, you can do that. We have a ZOS started task version of Ivory Service Architect. We have a version of our server that runs directly in your CICS region, or if you choose to deploy it onto the IFL, Linux on Z, you can deploy it there. From what I understand, the IBM solution runs as a part of the Liberty Profile server, so that would just be something that you would need to be mindful for. And kind of a follow-on question to that from the same folks, what is the cost of running this on ZOS in terms of MIPS and storage? And this is kind of one of those your mileage may vary questions. I can tell you that given the transactional volumes that we see going through our ZOS server in the order of 40 to 50 million per month, the overhead is very, very minimal. But if resources are something that you're sensitive to, we do have a lot of customers who are running this on a Linux server, running a Java version of our server under Linux. So that can either be a Windows-based Java or a Linux-based Java. So you've got a lot of flexibility as far as where you want to and where you can deploy our Ivory server. Let's see here. What level of knowledge and skill of the mainframe do you need to build an Ivory API? That's another great question. As I said earlier, if you would step through our wizard, it asks you several questions like, what's the name of your program? Well, most people can walk down to a developer and say, you know, if I need to pull a customer profile, what program do I run? and then give you access to the data maps and tell you what fields you need to put in and what fields you can get back. And you can literally build web services in a matter of minutes with our server. Let's see, we talked about, here's another question. You talked about CICS programs and COM area. Well, what about applications that use channels and containers? Another great question. If your application requires channels and containers, you have the ability to do that. That is not a problem. Next question, we're implementing DB2 ZOS RESTful services. Can this tool also interface and to create and manage these services? Absolutely. One of the features in Ivory Service Architect, and I kind of alluded to it in one of the drawings here, and actually I could probably go back one slide. If you see right here, right after this blue triangle in the middle of the screen, we're actually making a web service call right from within a web service. So if you've got a ZOS DB2 RESTful service and you want to call that right from within an orchestrated flow, you absolutely can do that. Let's see, besides easily creating APIs, the GT also manage the APIs and expose them to the outside. We do not have currently a repository to house our services, but you can certainly put them into any common repository. But we do also support WSDL discovery. So if you give someone the URL of a service, they can certainly just go out on their own, ping the server, and get the WSDL contract for that particular service. Well, this is an interesting question. Can I call an assembler program from this product? As crazy as that sounds, you absolutely can. We have a special function within Ivory called our delegate processing, which allows you to call any language that is native to the platform where the server is running. So if you're running it on the mainframe and assembler is a native language there, you have no problem running the server there. And Janine, at this time, it looks like we're getting down to our last question. So I guess in closing, I'd first like to thank Harry McCord for co-presenting with me today. I'd also like to thank all of you who attended our webinar today. And as I said earlier, I hope you found the information to be both timely and valuable. And finally, I'd like to thank Janine and the folks at IBM Systems Magazine for all they do for the mainframe community and for hosting our time together today. I hope you all have a great rest of the day and look forward to speaking to you soon. And now, Janine, I'm going to turn it back to you for some final thoughts and housekeeping.
Thank you, Don. I will go ahead and thank our attendees, too, and thank you for your participation today in the form of some great questions. A reminder that later this week, we will be sending out a follow-up email with a link to the recorded webinar from today, so be on the lookout for that. That concludes our webinar. Thanks again, and have a great day.